Hey guys, and welcome back. Today we're going to be solving systems by elimination. This is actually my preferred way of solving systems. This is only the first part we're going to solve using elimination, specifically focused on addition. Okay, so I'm actually going to put a note on my learning target page. We're going to write and solve systems of two equations and two variables like we have been doing. I'm going to put a little star and say specifically by addition. Okay, so if I say to solve using addition, I'm talking about using one of the elimination methods. So to be successful at this, we're going to, one, be able to solve a system algebraically. Again, we're not going to be using a graph. And two, identify and explain the number of solutions a given system has and justify a reasoning. There may be times where there's one, none, or infinitely many solutions. So let's take a look at the main idea here. Again, I've listed out a set of steps for you to reference. I'm not just going to read these to you and have you sit there bored because I'm reading off of a slide. I'm going to reference this list as I'm going through each example. So let's take a look at the first example. All right, so this one we're just trying to identify which method would be used best for each one of these systems. So I have over here my two categories, the substitution method, which we learned yesterday, and then today's method, which is the addition method, also known as the elimination method. Okay, we're going to end up eliminating one of the variables using particularly addition. So what I want you guys to look for in order to use the addition method is for the variables to be lined up, and one of the variables needs to be an additive inverse. Okay, I'm going to write that at the bottom. An additive inverse. Okay, an additive inverse means they have opposite signs with the same digit. So, for example, in this first system that I see right here, I see additive inverses right here. The b terms, one is positive 5 and one is negative 5b. So if I were to add those two things, it becomes 0. That's called an additive inverse. So I can take that system and put it under the category of the addition method. So I've got 2a plus 5b equals 17. And 6a minus 5b equals negative 9. That's our first system in the addition method. So we got that one. Yesterday we talked about the substitution method and how one of the variables needs to be solved for. If I look at this second system right here, I see y equals. That means that y is solved for. If you recall from yesterday, we would circle what y is equal to and point to the y in the opposite equation and substitute it in. So I'm thinking this system is best solved by substitution. So I'm going to write that one in the substitution column. Y equals x plus 3 and 2x minus y equals 7. So we got that one. So now let's look at the last two systems here. I again am seeing an additive inverse, positive q and negative q. If you added those two together, it would become 0. So that's going to go in the addition method category. Got p plus, that's not a plus sign, p plus q is equal to 7, and p minus q is equal to negative 10. Okay. Last one, oh, that was a little messy. Last one, we need to figure out if it's substitution method or if it's addition method. Again, I see an additive inverse right here with 7x and negative 7x. If you were to add those together, it becomes 0. So I have a third system in the addition method. 7x plus 2y equals 10, and negative 7x plus y equals negative 16. Now, the reason why I'm having you practice placing these systems in different categories is because when you look at a system, you need to make a choice of which method is going to be the most efficient, which method is going to save you the most steps. Now, substitution method has a lot of steps, so we should probably, after this, take a look at how many steps it would take to do something like the elimination addition method. So right now, all I want you to do is identify, based on what we talked about, which method would be used best on this system. Go ahead and give this one a try. So in this second example, we're actually going to use the method of elimination by addition. So really, we're going to treat this system like a giant addition problem. In fact, the first thing that you should do is check to make sure all of the variables are lined up. So I see the x's are lined up, I see the y's are lined up, and I see the regular numbers are lined up. That's good. That's what we want. So the way that I do this is I actually make it into one giant addition problem. And I go like term by like term. So I want to add the x's together, I want to add the y's together, and then I want to add the regular numbers together. And the equal sign is just going to drop down exactly where it is. So 2x plus 6x, that's 8x. Now, since 5y and negative 5y, when you add them together, become 0, they actually go away. We don't have to write 8x plus 0. So we can cross off the additive inverses. Then we just do 17 plus negative 9, which gives us 8. And now we have a new equation that we can solve. The one thing I have to do here to solve for x is just to divide by 8. So I get x is equal to 1. Now, if you remember from yesterday, in order to solve a problem like this by substitution, that was like from example 3, that big, long, drawn-out problem with all the fractions, all that ickiness. It was terrible to have to use substitution in a problem like this. So when you see the variables are lined up like this, we can use this very quick and easy method by adding. But again, we're only halfway done. We want x comma y. So let's plug in that x is equal to 1 into either one of the equations above, into either one of these original equations. It really does not matter which one, just pick one. So I'm just going to pick the very top one, 2x, x is 1 though, so I'm going to plug in the 1 for x. So 2 times 1 plus 5y equals 17. Well, 2 times 1 is 2, plus 5y equaling 17. I got to get rid of that 2 first. So 2 plus 5y minus 2 is equal to 17 minus 2. The 2's cancel, and I'm left with 5y is equal to 15. Divide by 5 on both sides, and we get y is equal to 3. So my solution is going to be x comma y, so 1, 3. Before we stop, we should definitely also check this to make sure we did everything correct. So 2 times 1 plus 5 times 3, does that equal 17? 2 times 1 is 2, 5 times 3 is 15. 2 plus 15 definitely does equal 17. Second equation, 6 times 1 minus 5 times 3, does that equal negative 9? Well, 6 times 1 is 1, 5 times 3 is 15, and 6 minus 15 does equal negative 9. If you need to double check that, type 6 minus 15 into your calculator. It's going to get you negative 9. So how about you guys give this method of addition a try in your U-Try. right, so in this example, I just wanted to give us a couple of different types of equations where we may have to change something about them first in order to apply the addition method. So if we take a look at the first system we have here, part A, we have x plus y equals 8 and x plus y equals 10. Well, let's use that same logic that we used on previous examples where, let's say, we know what x and y are. Let's say x is 2 and y is 6. So 2 plus 6 equals 8. Could 2 plus 6 equal anything other than 8? No, it has to equal 8. So here we have x plus y equaling 8, but then x plus y also equals 10. That doesn't quite make sense. This is going to be one of those situations where we have no solutions. Okay, so where the left side matches, okay, so this matches, but then the right side does not match. This means there are no solutions. Okay, so keep that in mind when you're solving. I know we've done the no solutions, infinite solutions thing a lot, but we need to make sure that's always in the back of our head. When you're solving a system, you could have one solution, and that's going to be when you find the answer, but you should always keep in mind the option of having none or infinite. So let's take a look at part B. Here, I don't see anything that are additive inverses. I also don't see the left side matching the right side. But if I do something to the first equation, like multiply the entire first equation by 2, if I use my distributive property and do the 2 to all three terms, 2 times 2x is 4x, 2 times negative 3y is negative 6y, and 7 times 2 is 14. So really, when I times this first equation by 2, I get the exact same thing that's in the second equation. Remember, when we end up changing something, but we do it to everything, it becomes the same exact thing. That's going to be infinite solutions because they're the same line. If they're the exact same line, then they're going to intersect everywhere. So that one was infinite solutions. And lastly, part C, again, I'm seeing between the x's, it looks like I can take the first one and multiply it by 3 to get the second. In the y's, it looks to be the same pattern. 5 times 3 is 15. However, 9 times 3 is not 33. Let's actually multiply the first equation by 3. That means we need to multiply all of the terms in that equation by 3. So we'd get 3x plus 15y is equal to 27. Now, since the left sides match, but the right sides do not, that means this is going to be another no solutions. Okay, so still practicing, looking out for if we cannot find what the solution is, what would be the option, the no solutions or infinite solutions? So go ahead and give this a try in your U-Try. All right, so I've got one last example for you guys, the word problem. It says 2 runways at an airport, runway A and runway B have a combined length of 20,500. That's actually one of the equations that we're going to create. Runway A and runway B have a combined length of 20,500. Those words combined length, that's telling me that I need to add them together. So I'm going to create my first system. First, I'm going to define my variables. Let's say that the letter A is the length of runway A. And we'll call B the length of runway B. So in the first sentence, it says add the two lengths together, A plus B, and that should equal 20,500. The second sentence that they write says the difference of their lengths is 5,500 feet. Well, difference would mean that we need to make a subtraction problem. So A minus B is equal to 5,500. So now I can see that the B terms are additive inverses. Positive B plus negative B, that's 0. So I'm going to change this into a giant addition problem. So A plus A, that's 2A. Positive B plus negative B goes away, and we're left with 26,000. Divide that by 2. We get that A is 13,000. Now we need to plug in for B. It doesn't matter which equation we plug into. I'm just going to plug into the first one. So I've got 13,000 plus B is equal to 20,500. Subtract 13,000 from each side. We get B is equal to 20,500 minus 13,000. That's going to be 7,500. So now I should always make sure I answer the real life question with a real life answer. So at the bottom, I'm going to put my actual response. Runway A is 13,000 feet. And runway B is 7,500 feet. That's going to be my answer. I want to make sure all of my answers are in the form that their questions are in. So if their questions are real life, then your answers should be real life. So let's try this on your last U try. Alright, ladies and gentlemen, so that concludes our examples for solving by elimination using addition. We were able to write and solve systems of two equations and two variables. Our success was that we were able to do this algebraically. We used the addition method, okay, or the elimination by addition method. We identified this in the first example, and then we actually did this in examples 2 through 4. We also identified and explained the number of solutions a given system has, and we justified this reasoning. We did that in example 3. So go ahead and grab your practice, complete it, and ask any questions if you have them.